Go and price a stick of memory for your computer. Not a graphics card, not a processor, just memory. The most boring, most commoditized component in the entire machine. The part that was never supposed to be interesting. A year ago, a 32GB kit cost you $90. Today, the same kit closer to $500. And it isn't only you. The cheap laptop is quietly disappearing. Gartner now expects the entry-level PC to vanish from shelves altogether. Phone makers are now stripping features out of budget handsets just to absorb the cost. And in June, a group of consumers, a small repair shop, took the 3 companies that make almost all of the world's memory to federal court in California. So something has seized up, and every explanation you have heard for it is a version of the same sentence. AI companies bought it all. That's true, but it's also not the answer. Because if demand were the whole story, the fix would be obvious. Build more. Samsung, SK Hynix and Micron are 3 of the most capable manufacturers on Earth, sitting on the largest profits of their history, with every possible incentive to flood this market. But they're not doing it. They cannot do it. Today, we're going to unmask the reason why, and a handful of companies sitting quietly at that choke point. Most people think this is a factory problem. That somewhere in South Korea, there is a fab that needs building, a ribbon that needs cutting, and 18 months later, the shortage ends. Well, they're looking in the wrong building. Samsung's memory division said it out loud on July's earnings call. Supply gets worse next year, not better, and the squeeze runs through 2028. Micron's chief executive went further. He told investors he has no line of sight to when supply catches demand. That is 3 years of shortage, forecast by the only people on the planet with commercial reason to promise you the opposite. The constraint is not where the chips are made, it's where they are stacked. And the machines that do the stacking come from a short list of companies small enough to write on a napkin. A Korean firm called Hanmi Semiconductor, a Hong Kong listed group called ASMPT, and a Dutch company almost nobody outside the industry has ever heard of, BE Semiconductor Industries. 3 companies most investors have never really typed into a search box. Between them, they decide how much AI memory the world is allowed to have. And here is how that happened. You see, the memory you stack into an AI server is not the same stick that you'd slot into a board. It's actually a tower. To feed a modern GPU, you have to put the memory almost close enough to touch the processor, and then open the fire hose between them. The current generation moves 2048 bits at once per stack. The stick of RAM in your desktop moves 64. You see, you can't do that sideways. There isn't enough edge on the chip to attach that many wires to. So the industry went vertical. Take a memory die, grind it down until it is 30 microns thick, about 1/3 the width of a human hair. Thin enough that it flexes like foil, and it wraps if you look at it wrong. Now, drill more than 8,000 copper channels straight through it, top face to bottom. Then do that 12 times and stack them. 12, one on top of another. The entire finished tower, 12 layers of silicon, a control die at the base, and every layer of copper joining them has to come in under 775 microns, the thickness of one ordinary unprocessed silicon wafer. And that is the limit. The standards body raised the ceiling to let this generation even exist at all. You are fitting 12 chips into the space of one. The roadmap says 16. And then comes the part that decides everything. Each layer has to be pressed down onto the one below it, heated and aligned to the tolerance measured in fractions of a micron. Thousands of copper contacts on the underside of one wafer-thin die have to land on thousands of copper contacts on the top of the next. Every single one of them. Miss on the second to last layer, and you have not lost the chip, you have lost every perfect layer underneath it, and every hour of work that went into joining them. So the obvious question? Buy more machines. But here is where it gets mind-bending. The tool that does this is called a bonder, and the next generation of it is stranger still. It throws the solder away entirely and welds bare copper directly to bare copper. No bumps, no gap, 2 surfaces simply become one. To do that, it has to place a die to an accuracy of about 100 nanometers. The copper faces have to be polished flatter than any mirror you have ever looked into, and there can be no particles on the surface. Not few, none. Because a single speck of dust does not create a small defect, it creates a void up to 20 times larger than the speck itself, and the bond fails. So these machines are built by hand, in clean rooms, and they come out slowly. Besi, the company leading in this field, told investors it has now stretched its capacity to around 240 of them a year. That is the leader at full stretch, and you cannot simply order one of these and switch it on. Before a chip maker will run a new bonder in production, that tool has to be qualified, proven on their line, on their process, on their yields, generation by generation. Besi's chief executive has said it plainly, getting one qualified at a single logic customer took over 3 years. 3 years for one machine to earn the right to be switched on. That is the moat. Not a patent, not a factory, time. And the fact that nobody in this industry can afford to spend it twice. So who actually makes these? Well, it's not who you'd guess, and it's not the names that trend on a Monday morning. The largest is Hanmi Semiconductors, in Seoul, a company that supplies most of the bonders stacking memory today, and one that most of you cannot buy because it has no US listing. Micron named them a top supplier last year. In June, SK Hynix placed an order for their next generation tool large enough that Hanmi was legally required to disclose it. Then there's Besi. Besi does not build machines stacking today's memory. It builds the machines that are meant to stack tomorrow's. And as of April, all 3 of the world's memory makers have Besi's hybrid bonders sitting on the floors being evaluated. Besi will not tell you which one is which. What Besi will tell you is that its last 12 months of orders were the largest in the company's history. And that is the whole bet stated plainly. A company selling the tool for a transition that has not fully arrived, priced today as though it already has. So what does this break? 2 things to watch. And the first one is the risk that nobody in this story wants to mention. For 2 years, the industry assumed that the jump to the bumpless copper welding would arrive with this generation. It didn't. The current generation is shipping right now, and it still uses solder because the standard body relaxed the height limit, and because Samsung and SK Hynix each found other ways to pull the heat out of the stack. So the transition slipped to the generation after. It could slip again, and here's the part that should genuinely give you pause. Hanmi, the company that sells the current tool, says publicly that its bonders are good enough for the next 2 generations of memory, and that the switch doesn't happen in volume until the end of this decade. The market leader is telling you the revolution is years away. That is the simple largest risk in this entire thesis, and it sits directly underneath the valuation. The second thing to watch is concrete, and it is already being poured. Hanmi is finishing a new plant in Incheon in the first half of next year. Besi is expanding too. Both are building for a transition that neither of them can date, because the only thing that they both agree on is that when it comes, there will not be enough machines, and there is no way to hurry them. Step back far enough and the shape of this is familiar. Retail bought the memory makers. It was the obvious trade. And it worked. Those profits were real and they was enormous. But the memory makers are the ones who got squeezed and then got paid. They are the middle of the chain. They are not the top of it. The money that actually understands this industry went one layer further. Not who sells the memory, but who sells the ability to make it. Not the tower, the machine that builds the tower. One impossible layer at a time. That is a much shorter list of companies. It is a far harder list to get onto, and it is a list that does not change when the price of a memory stick finally comes back down. Which is the part worth sitting with. Almost everything in modern world now runs downstream of a handful of machines, assembled by hand in a handful of buildings. The price of your laptop, the cost of an AI answer. Whether a repair shop in Florida can still afford the parts it has stocked for 20 years. So here is my question for you. When this shortage finally breaks, and it will, do you think the money will have been made by the companies that sold the memory, or by the ones that sold the only way to build it? Let me know in the comments below. This is Sundance from my Stock Harbor. Keep your course steady.